Today we are going to take a look at section 1.4, and it just continues our discussion of fractions. We started that discussion last time, and we're going to continue it this class period. In particular, when we looked at fractions last time, we looked at simplifying fractions, right? And multiplying, and a little bit with dividing and reciprocals. So definitely those are the easiest operations to work with fractions, which means what we're left with is addition and subtraction. And addition and subtraction, while they are sort of the building blocks when you start elementary school with real numbers that are not real numbers, with whole numbers, excuse me, they're harder to work with fractions because we have to have common denominators to make that work. And I'd like to kind of talk to you a little bit about why that happens from a graphical perspective. So addition, in order to add fractions, the denominators must be equal. And you have this sort of space right here on your page, and I'd like for you to make two fraction bars. They're just rectangles that are approximately the same size. And they're going to go with what's on the next part of your page, which is on my next slide. So yours is all contained a little bit better than mine. It says to consider 1/3 and 1/2. So the first fraction bar I'm going to draw and that you're going to draw is going to be a fraction bar representing 1/3. So you're going to split it into thirds, fairly nicely. You're going to try. And you're going to shade in 1/3 of it. So that's the fraction 1/3. And then you're going to do the second fraction bar as 1/2. So you're going to split it in half. And you're going to shade the second fraction, first box. And this is 1/2. So we're considering adding 1/3 and 1/2 together. The problem with this picture, as it's currently drawn, is that the boxes are not the same size. So you cannot add them together the way that they're currently expressed. Okay? Now, I'm going to copy and paste this to the slide that I'm on. You don't necessarily have to redraw yours, but you can if you want to, because you do have a space to do so. So if I take those same fraction bars and I divvy them up a little bit differently so that my boxes are the same size, then I will be able to combine them in a way that's reasonable. So what I'm going to do is I'm going to take the boxes in the first diagram and I'm going to split them in half. And just so that you can see where I've split them, let me do them dotted. So I've split these in half, like so. And then on the second box, I'm going to split them into thirds, each of the boxes into 1/3. They're not perfect pictures, but I think you have the right idea. At this point, when we split them this way, all the boxes are the same size, right? So it sort of makes sense to reorganize my display. It's almost like having one pizza box, right, that's pepperoni, but there's 3 slices left, and then there's another pizza box with sausage, and there's 2 slices left. You don't put the 2 pizza boxes in your refrigerator. It's a waste of space. You consolidate them, right? It's the same idea of what we're trying to do here. We're trying to consolidate these 2 pictures and sort of merge them into one single picture. So let me take this one. I'll use it again over here. So we take the 1/3, divide each box in half, which we did. There's 2 out of 6 boxes shaded. 1/2 into 3 boxes, there's 3 out of 6 boxes shaded, and now the boxes are the same size. Kind of mentioned that already. That's not what I tried to do. Let's try again. Okay. I don't know where that slide went. That's fun. Okay, now I'm missing a slide. So it says if we take the 1/3 and the 1/2, it was on there just a second ago, we have, to divide the boxes in half, we have 3/6. So the picture that I was trying to draw was this one. This is what I was going to draw at the bottom of your page. It's taking one of those and then taking the 2 from here and repositioning them, much like my pizza box illustration. And what I now have is I have all the same boxes. They're all the same size, so I can shade them in a different order. And there's 5 out of 6 of these boxes shaded in. And what's happening then is that I have this expressed as 2 out of 6 and 3 out of 6. So I now have 5 out of 6 shaded in boxes. So that's what happens when we're working with fractions. is that we are trying to find these common denominators so that we are able to combine the two values together. And this is a picture showing that combination, even if I lost my slide. So what we're going to do is we're going to be looking for common denominators, or maybe least common denominators, if it's easy enough for us to see what that would be, for fractions so that we can add them together. If they already have common denominators for adding or subtracting, then I'm already, sort of one step ahead of the game. I don't have to worry about getting them because they're already there. So this first couple of examples have that feature, right? Both of the denominators on problem number 1 are 10s. So I have 1 out of 10 and I have 3 out of 10. And if you were imagining my picture like I did before, but with 10 little boxes, we'd shade 1, we'd shade 3 of them, and we'd have, of course, 4 of them shaded. So this is it's 4 tenths. It's not 20ths, right? Think about this picture over here. I didn't end up with 12 as my denominator. There's still boxes are still the same size. They're 1/6 of the whole picture. So the denominator is telling you how big your boxes are is really what the deal is. And the box size doesn't change when I add values together. It's just the numerator, that is how many boxes that are shaded in, that's changing. So I have 4 out of 10. But you'll notice in the directions it says that we're always going to reduce to simplest form, which is what you guys did on your homework from last time. So how would I change 4 out of 10 so that I've reduced it? Yeah, I'm going to divide top and bottom by 2, right? So I'm not really dividing by 2. I'm dividing the individual numerator and the individual denominator by 2. So this ends up giving me 2/5. And that's where my problem would then end, is with the reduced form. So on the next one, I have 3/5 minus 1/5. Again, the size of the boxes, the fifth part, does not change when I subtract. And I'm just subtracting straight across the top. So 3 minus 2, or 1 is 2. Happens to be the same answer as the previous problem. That's just happenstance, and we're done. There's no reducing to do when I get down to 2/5, right? Yeah. All right, any questions on that one? Okay, this direction on number 3 does not ask us to combine this. There's no addition between them or subtraction between them, nothing like that. The directions are simply to find the least common denominator. So as we're looking for least common denominator, what we want to do is we want to break down the denominators that we are given and compare them. So 10 breaks down into
2 and 5.
2 and 5 will do us. And how about 18? There's a couple of different ways I could start.
2 and 9.
Okay, 2 and 9. And typically speaking, we'll keep going with the 9 becoming the 3 and 3. If on this one we didn't do that, it would be okay, but in general it might not. So I'm just going to break it down into its primes. Everybody good so far? Okay, so what you're doing is you're going to try and find all the common factors first. So if you take a look at what they have in common, what factors do they have in common?
2 and 3.
Just the 2 first, just the 2. They each have a single 2 in them, so my least common denominator will also have a 2 in it. Now, if I stopped there, I wouldn't have least common denominator yet, but I would have the greatest common factor on this one. Right? It's the biggest number that divides both the numbers. To get the least common denominator, I need to pick up all the leftovers now, which includes a 5, and it includes a couple of 3s. So all of these values multiplied together will then give me my least common denominator. So let's take a look. What is 2 times 5?
10.
And 3 times 3? Which would be 9. It's okay. And then 10 times my 9 would be 90. Yeah. So my least common denominator is just the 90. This isn't the only way to find least common denominator. There are other options, but this one works really nicely for sort of blending into what happens when we have variables and denominators. So it's the one I kind of want to settle with for us working on today, is this particular method, since it has that generalizability. Okay, so now what we're going to do is we're going to take a look at some examples that don't have common denominators. So the first one is 2/3 plus 1/6. Now, if you want to, on any of these problems, you can always just multiply the two denominators together. That is an option. It doesn't find you the least common denominator, but it will find you a common denominator. So please don't write this down, but just recognize that it would actually be correct to do this. Add them together across the top. Your common denominator would be an 18, and then you'd reduce. You can do that. So sometimes that's the easiest thing to do because the numbers are just, they're weird, or you're not seeing anything that's in common from the get-go. On this one, that's a bit of overkill because 6 is already just a multiple of 3. So on this one, it's pretty straightforward enough to see that if I simply multiply the 3 by 2, then I'll have a 6 as my other denominator and I can add them. It'll keep our numbers a little bit smaller if we happen to recognize least common denominators instead of just common denominators. So now I have the 4 over 6, because remember, anything I multiply the bottom by, I have to multiply the top by. So this became 4 out of 6. And 4 out of 6 plus 1 out of 6 is 5/6. And at this point, it's possible here that you might have to reduce still. Just like we did on the very first one, right? You could do that, but this one doesn't reduce, so we're finished. Any questions on that? Okay. Now the next ones, 8 and 3, they actually don't have anything in common, right? They don't. So what I alluded to before as being a possibility is actually the only way to proceed in a reasonable fashion on this one, just using the multiples against, with one another. So the 8 gets multiplied by 3 top and bottom, and the 3 gets multiplied by 8 top and bottom. And that will create the least common denominator because they didn't have any factors in common to start with. So on the top I have 15, on the bottom I have 24, and then on the top I have 8, and the bottom is 24. So it is 15 minus 8. You guys know? 7. It's 7 over 24. You're right. Okay, again, we would look to see if they reduce. Do they reduce? No, they don't, so we're finished on that one. All right, one more in this set. 2 over 7 minus 1 over 9. What will I need to do on this one?
What we did on this last one.
You're right. Okay, so Emily, tell me what I want to multiply and by what number?
The 2 you want to multiply by 9, and then the 7 by 9, and then the 1 by 7, and then the 9 by 7.
Excellent. Everybody good with that? So my denominator will be a 63, right? And my top numerator, my first numerator rather, is 18. My second numerator is 7. 18 minus 7 is 11 over 63. 11 and 63 have anything in common? No, they don't, so we're done. All right, so when we are working with conversions, this is on the bottom of your page, and then the example's on the top of the next page. That example on the top of the next page is that 15 over 2. Sorry, there's not a whole lot of space up there. There's a formatting piece that kind of got messed up. One of the things that we're going to finally hit in this section is converting into mixed numbers. Okay, so when we convert into mixed numbers, we're just using division. 15 with the fraction bar on top of the number 2 really just means 15 divided by 2. It's just another form for it. So we can actually go back to, I don't know, somewhere in like 2nd or 3rd grade when you did division like this. And you can do 15 divided by 2. So I'm quite aware that your calculator can do 15 divided by 2 without doing some work to show it, but you're going to show me something, all right? Some kind of work that you're going to show me as you do the divisions. I'm going to give you an example of some kind of work that would be acceptable. So if we do it like this, 2 goes into 15 how many times? 7. We'll put a 7 on top. 7 times 2 is 14. And we subtract. 15 minus 14 is 1. Now, your solution, and I know that it's back in there, but we haven't maybe done it in a while, is the 7 on top with the remainder 1 as the numerator, and the divisor, 2, which was already our divisor, is still in the denominator. So this is 7 and 1/2. We're not going to write 7R2. That is not what we're going to write. Okay, it's 7 and 1/2 because we're turning it into a mixed number. All right, I have a couple more examples that are a little interesting. So we're going to talk about how we convert into a percent. And because of the way we're going to take a look at it, one of the things that I want you to remember is that a percent is just a portion out of 100. Okay, so when somebody says 52%, they mean 52 out of 100 people if they had 100 people. Like that's what they're talking about, 52 out of 100. So having the number 100 on the bottom is the desirable value. So when I see 14 out of 100, I'm already where I want to be. So sometimes we're going to move decimal places, sometimes we're going to get hundreds in the denominator, and sometimes we're going to actually have to use division. So the first one that I'm going to use here happens to have the number 100 on bottom already. So what does it mean? Well, it just means that the value on top is already the percentage. 14 out of 100 means 14%. Like they're simultaneous, like they're interchangeable meanings for the same expression, 14%. So I don't have to do any work to get that. Now, if I'm asked to turn it into, this one says converting forms to a percent, move decimal when possible. So if I'm asked to do something into a decimal form, then we would move the decimal point. So if I'm trying to move into decimals, depending on how your questions are worded, then you would take that 14% that has the decimal here and you'd move it 2 to the left. So you would have decimal, 1/4. That's the decimal form. So we have a fraction form, 14 out of 100. It's not reduced. That's okay. We have the percentage form, 14%. And then we have the decimal form, 0.14, or 1400ths as a decimal. Now, there's one that I think is missing that I want to sort of draw your attention to. Actually, let me I'm going to put in a couple extras here because when you get to your homework, I want you to have an idea of what to do when different things pop up. So these are just additional examples that I'd like for you to look at. I'm going to do 4 out of 50. We'll do that one as our next example. So when the denominator makes itself, or when it is easy to make that denominator a 100, that's what we want to do. We really like 14 out of 100. It's easy to move between all the different forms of things when 100 is your denominator. Well, 50 is not as pleasant of a denominator, but it's easy to manipulate. What would I have to multiply 50 to get 100? 2. And just like always, if I multiply on 2 on bottom, we multiply by 2 on top. So we get 8 out of 100. So as a percent, that's 8%, because the 8 is out of 100. And then as a decimal, if we have that, here's my decimal point right now. And if I move it 2 to the left, that's 1, and then I move it 2, I need a 0 here. So as a decimal, it's 0.08. Okay, so if you can change the denominator and make it 100, that's fabulous. And there are numbers that are easy to do that with. 50 is one of them. Can you give me another example of a number that's easy to change into a 100 in the denominator? 25 would be one of them. 75 is a little harder, actually. It's easy to turn it into like 150, but it wouldn't be quite as easy to turn it into 100. 10 would be good. 20 would be good. 4, 5. There's lots of examples of things that will work, so pay attention to them, but not everything will work. So Angelica mentioned 75, and it feels like, well, it's in that family, right? It would work too, but it actually doesn't end up being quite as easy to work with. Another one that's kind of in that family that's not as easy to work with is 8. If I multiply 8 by different values, it's very difficult to get to the number 100, at least multiplying by whole numbers. In fact, I'd have to multiply by something that's in a decimal form in order to get there. So if I've got a value like the 8, or if I had a 75, or if I had a 3, or if I had the number 40 or something like that, where it's difficult to get there, what we end up having to do is we actually end up having to do the division, much like we did on this mixed number one that we had before. All right? So the 8 is in the denominator, so it goes on the outside, and the 3 is in the numerator, so it goes on the inside. And we do decimal now, division. So the 8 does not go into the 3 at all, so we have a 0 up here. But if I consider the number 30, 8 goes into 30 how many times? 3. Yep. And there's my decimal point moving up. 3 times 8 is 24, leaving with the 6. And I keep going until I can get this to either end or to recognizably repeat. 60. How many times does 8 go into 60? 7 times is right. 56. Yeah, you're close. No worries. So we're at 4 as a remainder now. Let me shift this up just a little. Okay, again, I pull down another 0. And how many times will 8 go into 40? 5. We finally end the thing because 5 times 8 is, in fact, 40 with no remainder. So it's either going to end like this one did, right, where it stops and there's no remainder, or you'll start to recognize a repeating pattern where the same number comes out, like you get 0.33333 repeating kind of thing. You know it's never going to end in that way. So when we're looking at this, that's my decimal form, right? 0.375. And if I want this is my decimal, as a percent, then I would need to move the decimal 2 to the right to turn it into a percent. We were moving it 2 to the left before because we went from percent to decimal. And so my percentage would be 37.5%. Okay, so it depends on what kinds of numbers the denominator are, or the denominator is, as to which of those methods is your preferable method. Our last example is a conversion where we're actually given a percentage now. So the other ones I was giving you the fraction, and now I'm giving you a percentage. So this one's actually telling us that we're going to turn it into a decimal. We'll turn it into the decimal form and into the fractional form both. So this is it's converting decimals to percents to fractions. Place the value over 100 and reduce. Right? 12%. What does it mean? Well, it means 12 out of every 100. Right? That's what it means. Now, as a decimal, we can simply move the decimal point from here to the left 2, and we can be done. That's a decimal point 12. But if I want it in a fractional form, it means taking the number 12 and writing it as its percentage, its portion out of 100. If it's not able to be reduced here, you're done. But this one is able to be reduced. What could I divide both top and bottom by? 2. If you don't recognize anything else, we both recognize they're even. That's a good place to start. That leaves me with 6 over 50. Am I done? Nope. What else? 2 again. Which leaves me with 3 out of 25. Am I done? Yeah, I am at that point. 25 and 3 don't have anything in common. And so at that point, I finish. Any questions on that? All right, so you should have your homework with you to start taking a look at in class today.